Now, in continuation with our this orbital velocity, satellites, etc., all these things, let us now move to our next topic, that is the geostationary satellites. So we have here the discussions regarding geostationary satellites. Okay, first of all, what is the meaning of geostationary satellites? Look, geo means earth, stationary means rest, at rest. Satellites which appear to be stationary with respect to the earth's surface are known as the geostationary satellites. So geostationary satellites are those which appear to be stationary with respect to the surface of the earth. With respect to the surface of the earth, they appear to be stationary. But definitely there should be some conditions for a geostationary satellite to exist. You can write, following are the important conditions. Following are the important conditions for geostationary satellites to exist. What are the important conditions? Let us see. The important conditions are, you can write number one. The satellite must revolve, write down, the satellite must revolve in a plane, the satellite must revolve in a plane which is concentric and coplanar with equatorial plane. So what we have said, the satellite must revolve in a plane which is concentric and coplanar with the equatorial plane, like this. Suppose this is the earth, this is the equator, the shaded one is the equator, right? So satellite is revolving. In what way it will be revolving? It should revolve in a plane, the plane which is the same plane, concentric and coplanar. That means the plane in which the satellite is revolving, its center and plane both must coincide with those of the equator as shown in the figure. This is the first point. Second point, the period of revolution of the satellite, time period of revolution. So the time period of revolution of the satellite should be same as that of the rotation of the earth, means time period of the rotation of the earth about its own axis. That means how much it will be? 24 hours. 24 hours में अर्थ एक कंप्लीट रोटेशन घूमता है, तो सैटेलाइट का भी टाइम पीरियड ऑफ रिवॉल्यूशन वही होना चाहिए. थर्ड पॉइंट, द सेंस ऑफ रेवोल्यूशन of the satellite, geostationary satellite, the sense of the revolution of the satellite should be same as that of the rotation of the earth about its own axis. That is from, mind this, that is from west to east. It is always be revolving in the sense from west to east. If I see from here, it's from west to east. The sense should also be the same. That means the sense of the rotation of the earth and revolution of the satellite should also be identical. These three conditions must be satisfied for the existence of a geostationary satellite. Then only a geostationary satellite can exist. Okay? Now, suppose I find out here the height of the satellite. Means if I want to find out the height of the satellite, now the height of the satellite means h, I want to find out. For this, I can take the help of equation 11 or equation 12. Either of the equations can be taken into reference. I can use equation number 11 or equation number 12. Any you can use. Right. So, what will happen? If I use, suppose, equation number 12, okay, by equation 12, what will happen? T square is equal to 4 pi square by r square, okay, into r plus h, into r plus h cube divided by g. It should be like this. So r plus h cube should be 4 pi square g divided by g 4 pi. This will be just a minute. It is r plus h cube should be equal to g r square t square divided by 4 pi square. Look, g r square t square divided by 4 pi square. No problem. So what we shall get? R plus h should be g r square t square divided by 4 pi square to the power 1 by 3. So h should be g r square t square divided by 4 pi square to the power 1 by 3 minus r. You can take this equation. Let us take this equation as equation number 14. No problem. Okay. This is the height of the satellite. Okay, this is the height of the satellite. And if you want to use this formula, then in place of gr square, there will be capital G into m. That's all. Only this is the difference. So, for geostationary satellite, what will happen? Obviously, small g should be 9.8 meter per second square. R should be 6370 kilometer. Okay. T should be 24 into 60 into 60 second. This is, if we put all these values here, right, putting these values, we get h to be nearly equal to 35,930 kilometers. 35,930 kilometers almost. Nearly equal to 35,930 kilometers. This is the height of the geostationary satellite. Height of the geostationary satellite is found to be equal to this much value. Understood? So, this is regarding the height of the geostationary satellite. So, this is all about the geostationary satellite. Obviously, that means we can say for a geostationary satellite, the above conditions should be satisfied, right? And this satellite must revolve in an orbit which is at this, approximately at this height from the surface of the earth. Such an orbit in which geostationary satellites revolve are known as parking orbit. Parking orbit is the orbit in which the geostationary satellites revolve. We must remember this. So nowadays you all know that geostationary satellites have very modern techniques. With the help of the geostationary satellites, by launching these geostationary satellites, only the aerial view of the earth are obtained. We are getting the aerial view and all, okay, with the help of this geostationary satellite. It's a very important technique nowadays. So, dear students, almost we have come near to the end of this gravitation chapter. I think in the next class we shall complete this gravitation chapter also. Okay, so this is the end of the geostationary satellites. Thank you.